Do you need graph paper? I have graph paper.
I want to keep the line with the one that is connected.
Oh, I see.
Do you know how many like pages you think we'll need? Like.
I have no idea. What's up, Joey? Yeah.
I used to have a whole like wrapping paper notebook, but it's already been used. Now I gotta get another one.
How'd you rip that so clean?
That was the last one.
Are there a range? Would it be
Oh, I did do the range, yeah. What would the range be?
y is greater than 0, greater than or equal to 0, and less than positive at infinity?
Yes. So you could just say y is greater than or equal to 0. Perfect.
How do we solve for that?
There's not solving. You're just looking at the graph. So right here, our lowest point is 0, our highest point is an arrow, so that's infinity. Okay, so let's do more of these non-standard graphs. This next one, I'm going to have y is equal to, where did it go? The absolute value of x squared minus 1. This is not a v. How do I know this is not a v? Well, absolute value usually is a v, right? The parent graph for an absolute value is a v. Back to the beginning, if we could ever get there. Where's my parent graphs? There we go, parent graph, right? Parent graph is a v for absolute value. But how come this one's not a v? Because inside the absolute value lines is a quadratic. When it's a v, what's the degree of the x inside of it? 1. When it's a v, your degree is 1. This is not a v. What this is us taking a parabola, x squared minus 1, and then taking the absolute value of it. So on these problems, what I want us to do is first sketch the parabola. Or we can, if it's not even a parabola, sketch what's inside the absolute value line. Sketch the function inside the absolute value lines. And then after you're done with that, then you're going to take the absolute value of it. And guys, just so you know, that's actually what's happening with the v. Just to explain it to you, but because it's so common, we just know what it looks like. But if I have y equals the absolute value of x, what you're doing is you're taking and you're graphing y equals x. You guys don't have to do this, I'm just showing you. And when you're taking when you're graphing y equals x, that's a line. But then we're taking the absolute value of it. When you take the absolute value of something, for example, when I have the absolute value of -1, what does it become? +1. What about when I have the absolute value of +1? Doesn't it stay +1? So when you take the absolute value of something, it doesn't become the opposite, it becomes positive. And if it's already positive, it stays positive. So in this scenario, when it says y equals the absolute value of x can be negative, right? The number I plug in for x can be negative, but the outcome has to be what? Positive. So this is saying x can be negative, but y has to be positive. Where is y negative? Isn't it negative below the x-axis? So my whole graph that's below the x-axis, I don't make it disappear. I have to make it what? Positive. So how do I make this positive? I basically take my point. What's this point? Down 1, right 1, negative 1, up 1. So this was the point negative 1, negative 1. I made it the point positive 1, positive 1, right? I took the negative, I made it positive. So now this whole line just becomes positive. So it looks something like, oops, that. And this got turned positive. And that's where our V came from. That's where the V comes from. So essentially, it's never really just a V, but because it's so common, we just recognize it as a V. But really what we're doing is we're always just taking whatever in those absolute value lines, graphing it, and then taking the absolute value of it, which is exactly what I want us to do here. So, but this time what's inside the absolute value lines is not a line. What's inside the absolute value lines is a parabola. Julian, why do you look sneaky? What's going on? You keep laughing, and I know this isn't funny.
It's because David guessed what it would look like the W shape.
Oh, okay. Hysterical.
Yeah.
It's very funny. Okay. So what we want to do now is first start off by sketching this parabola. Forget about the absolute value lines. So I'm starting off with y equals x squared minus 1. Does this fit the standard form of a parabola with the shifting and stuff? Does this match the format? For the most part, I can manipulate it a little bit because we want it y equals a times the quantity of x minus h squared plus k. So I can manipulate it to look like it, where it's y equals a times x minus 0 squared minus 1. And now it really fits that format perfectly. Do we all agree our a is positive? So am I opening up or down? So we're opening up. My h is 0, so what does that mean? No horizontal shift. What about the k? The k is negative 1, so what does that mean? 1 unit down. You got it. So if you guys remember, for the parabola in the parent graph, where is my turning point? 0, 0. So I'm going to take that turning point, and all I'm going to do is move it 1 unit down. But now I still need more points, so I'm going to find the x-intercept. So my x-intercept is 0 equals x squared minus 1. So 1 equals x squared, so x will equal plus or minus 1. So we're here and here. I already know the y-intercept. What's the y-intercept since I plotted it? 0, negative 1. Do we need to actually solve it algebraically? No, we already found it. We're good. So now what we're going to do is we're going to graph this, or sketch it, I should say. Connect our points, and it looks something like that. Okay, now we did our first part. We sketched the function inside the absolute value lines. Now we want to take the absolute value of it. So again, our equation is saying y equals the absolute value of this function. So x can be negative. It's okay. What's inside the absolute value lines can be negative, but the y has to be positive. So I'm going to go to my graph. Where is the y negative? The y is negative everything underneath the x-axis. So I'm going to take everything underneath the x-axis, and I'm not going to make it disappear. I have to make it what? Positive. So I'm taking everything under the x-axis, and now I have to make it positive. So that key point underneath the x-axis is the point 0, negative 1. The first thing I'm going to do is make that point 0, positive 1. Made the y positive. And now this whole section has to also become positive. So how does this look? So the part that was already positive stays the same. So this pink was already there. Do we agree? But now after this point right here, it started getting negative. I can't be negative. I have to stay in the positive. So what happens is it hits that point and bounces up to that point. And now I have to complete my graph. So I go back down to that point. And the pink part was positive, so it stayed positive. So this whole part, if it's our final thing, gets erased. And as it was so funny, on David's paper, we have a W. Okay, yes.
Wait, why? How do we know to move it positive? Or no, how to move on the y-axis positive?
That one point, because it's saying y has to equal the absolute value, meaning anything that was negative in that y, we have to turn, in that point had to turn positive. So our point was originally 0, -1, but this y coordinate can't be negative. This y coordinate has to be positive, so we literally make it positive. So the 0, -1 becomes 0, +1. Okay, I'm going to do the same exact problem now, but I'm going to add one more thing to it. Bless you. Y equals the negation of the absolute value of x squared minus 1. So what have I added here? I've added this negative. So what this is essentially telling us to do is they're telling us, take the parabola, graph the parabola. Then after you graph the parabola, do what to it? Take the absolute value of it. Isn't that how we got the W? Okay, now it's saying, take that W after I take the absolute value of the parabola and negate it. Well, how do you negate something? What's the negation of a +1? -1. So to negate this whole positive graph, we're reflecting it over the x-axis to make it negative. That's what's happening. So this negative means really a reflection over the x-axis. So I'll write that down for you. That negative means a reflection over the x-axis. So are you guys okay if I just go straight to the W? Here, here, here. So this is what we had gotten before when we had sketched the absolute value of x squared minus 1. Now we're going to take the negation of that. So that negation is telling us to negate, put everything, reflect everything over the x-axis. It's like creating a mirror image. So instead of a W, we have like an M. And there we go. Okay, so that's the end of the non-standard graphs. Now we're going to talk about something called split rule graphs, which is the last part of day 2. This is the last part of day 2. So I want us to start off, I want us to graph f of x is equal to 3 if x is less than or equal to 0, -3 if x is greater than 0. Okay, so what I want to do here is I'm actually going to look at these separately. The first thing is saying f of x is equal to 3 if x is less than or equal to 0. Well, f of x is interchangeable with what? Y. So this is the same as saying y equals 3 if x is less than or equal to 0. What does the graph of y equals 3 look like? What is that? Think Algebra 1. Just a horizontal line, right? At 3. So let's go ahead and graph this. All right, so the line y equals 3, I go to where y is 3, and I draw a horizontal line. But there's a restriction on this. It's saying y is equal to 3 only when x is what? Less than, good. Only when x is less than or equal to 0. So where is x less than or equal to 0? Well, this is 0, right, for x, and then less than, wouldn't that be to the left? So this line only exists on the left portion of this. Is it on the right portion? No, so we erase the right portion of that line. Okay, so that's the first part of this. My dot will stay. So it's like a ray. All right, now there's another part of this. The next part of this is saying y equals -3 if x is greater than 0. So I'm going to go to where y is -3, and that's another horizontal line right here. But again, is it the full line? No, it's only -3 where x is what? Greater than 0. So the left part of this line gets erased. Now, can it be equal to 0? No. So instead of a closed circle, what do I have to put to show that it's not part of it? An open circle. And that's what this graph looks like. Not so bad, right? Okay. You guys try this one. F of x is equal to 1 if x is greater than 0, 0 if x is equal to 0, and -4 if x is less than 0. You might have trouble with that middle one, but I feel like some of you might be able to figure it out, that 0 if x equals 0. I feel like you'll mostly figure it out.
So quiet today.
Because Matt's not sitting there for Joey to, like, bother.
I think that's the problem.
I don't know about that, Joey.
It's God and it's quiet.
Because there's nobody physically in front of you for you to...
So he's the problem. He feels the issue.
Perhaps.
it shows if it opens upwards or downwards.
Okay, so for this one, we're going to have y equals 1 if x is greater than 0. So the way that looks like, what that looks like is I go to 1, I draw an open circle, and then we're going to the right. And then I'm going to skip the middle one for a second. They're saying y equals -4 if x is less than 0. So I'm going to go to -4. Open circle and go to the left. Okay, so now the middle one is y equals 0. Do we all agree the y equals 0 is essentially the x-axis? But the restriction is not if x is less than 0 or x is greater than 0, just at x equals 0. So what is that when it's just x equals 0? 1 point. Right there. No line. So all you have is a point.
Would it be an open circle?
Oh, sorry. No, equal. Equal to is a closed circle.
Wait, why is it one over there?
What happened?
Like, why is there one over there?
Because it's saying y equals 0, which is basically the line on the x-axis. But they're saying when x is just equal to 0. So where is x only equal to 0? X is only equal to 0 on this point of the line. So that's the only part that's in this. How many people got that? Yay. All right. So we cannot stay in the world of horizontal lines forever. So we are going to step this up a bit. Are we ready for it?
Horizontal lines is so nice though. Like, we're friends.
They were friendly, yeah? This next one won't be too cruel. The one after it will be worse.
Oh, yeah.
Okay, so this one I'm going to have f of x is equal to -1 if x is less than -1. The negation of the absolute value of x if -1 is less than or equal to x, which is less than or equal to 1. -1 if x is greater than 1. Not so bad. Okay, so what I'm going to do first, I'm going to leave the middle one right now. I'm just going to graph the first one and the third one, and we'll talk about the middle one after that. So let's graph these first two. So it's saying y equals -1 if x is less than -1. So I'm going to go where x is less than -1, right here, open circle, and y will equal -1. Everybody okay with how I got that? Okay, and it's an open circle, yes. So here, see this first part where it says f of x equals -1? If x is less than -1? Well, f of x is interchangeable with y, so y equals -1 if x is less than -1. So y equals -1 is a horizontal line. It's this yellow one right here. But the restriction on this was saying this line only exists where x is less than -1. Well, here's where x is -1, so we're just going to the left of that point. Okay, the next one is saying, I'm skipping the middle one, I'm going to the last one. So now we're saying y equals -1 if x is greater than 1. So where is x greater than 1? Right here. Again, it's not equal to, so that's why I'm making an open circle. And then they're saying y equals 1 for this side of it. Now the middle part. So the middle part is saying y equals the negation of the absolute value of x if -1 is less than x, which is less than +1. What is this? Y equals absolute value of x. What does that look like? A v. This is a v. And now this is a v that with a -a. So what does that mean? This a is frowning, right? It's opening down. So now we know we have a v. We know we're frowning. Has the v shifted, the parent graph shifted left or right, up or down at all? No. So I know my turning point is 0, 0. And I know I'm going opening down. But there's a restriction here. Because this v only exists between -1 and +1. So now I have to see what's happening to my v when x is -1 and what's happening to the v when x is +1. So what I'm going to do is make a little table to figure it out. So x, y equals the negation of the absolute value of x, and then my outcome y coordinate. So I want -1, so I'm going to plug in -1 for x. Y equals the negation of the absolute value of -1. Well, do we agree the absolute value of -1 is +1? So y just becomes -1. And then I want to figure out what's happening when x is +1. So y equals the negation of the absolute value of 1, which once again is -1. Now I'm going to plot these 2 points. So the first point was -1, -1, and the second point was 1, -1. Do we agree? All right, so now we plot. Now, when we go back to our restrictions, it was included, right? The point at -1 was included, the point at +1 was included, so that means closed circles here. So the first point we figured out was -1, -1. Isn't there already an open circle there? A closed circle trumps an open circle, so we close it. And then the other point is 1, -1. And again, on 1, -1, isn't there an open circle there? But remember, a closed circle overpowers a closed circle, so we'll close all of those. And then we know it's a v, so it looks like that. And that's our graph. All right, 2 more problems, and then we will call it a day.
Graphs, and then they're just going to ask us like a lot of questions about them.
Yes and no. We're going to get into inverse functions the next class. So we're going to learn how to find the equation of an inverse function and that stuff. But yeah, there's going to be obviously a decent amount of graphs. Okay, next one. What number was that? 3? 4. Okay, so here I want, not that one, not that one. Here it is, okay. F of x is equal to 2 minus x if the absolute value of x is less than 2, and 0 if the absolute value of x is greater than or equal to 2. I'm not going to worry about the restrictions right now. I'll worry about the restrictions in a minute. So let's just start off with our first equation, y equals 2 minus x if the absolute value of x is less than 2. We'll worry about that later. But what is y equals 2 minus x on a graph? What does that look like? The graph of that? What does it look like if we were to graph it? It's not a parabola. It's a line, right? It's a line. So I'm going to put this line in slope-intercept form, y equals mx plus b. So this is going to be y equals negative x plus 2. Sonia, you with me? So now in this, we have m is negative 1 over 1, and my y-intercept is 2. I'm going to go graph this now. So when I go to graph this line, I'm starting at my y-intercept, which is positive 2. And then my slope is negative 1 over positive 1. So I'm going to go down 1, right 1. And I keep doing that, down 1, right 1. And then up 1, left 1, up 1, left 1, up 1, left 1. And then we connect it with a line. Just freehand it. Something like that. Okay, so now I'm going to come to the restriction. Here's my line. The restriction is saying the absolute value of x must be less than 2. I don't anticipate that many of you remember this, since I think I know I taught it in chapter 1, but I don't believe we've seen it since chapter 1. We may have, but I don't remember. So right now, this is more than just an absolute value equation. There's the absolute value equation with an inequality. So it's absolute value and inequality. Anytime you have an absolute value inequality, we're going to get two different inequalities. Just like when you have an absolute value equation, we get two different equations. So for example, don't write this down, but let's say I had the absolute value of x equals 2. Don't we say x equals 2 and then x equals negative 2? It's the same idea with the inequality. I'm going to make two different inequalities. So this is going to be x is less than 2, exactly what's written there. And now what we're going to do is we're going to negate that 2. So I'm going to have x and negative 2. But guess what I have to do with that inequality sign? We have to flip it, because when you divide by a negative, don't you flip the sign? Now, here's the part everybody forgets. This is less than. So because it's less than, between the two inequalities is going to have the word and. If the inequality sign was greater than, it would be an or between the two inequalities. So this is saying x is less than 2 and x is greater than negative 2, which means we can write this as negative 2 is less than x, which is less than 2. One compound inequality. What does this mean for my line? This means that my line only exists between where x is negative 2 and x is positive 2. So where is x negative 2? Right here. Where is x positive 2? Right here. That means everything else that's not between those 2 points will get erased. So erase here. All right, and I'm still not done. Why is this graph still wrong? Well, no, but I mean just for this first part. Anya? They have to be open circles, because remember, there was no line here underneath the inequality sign. So that means it's not equal to, it's just open circles. So open circle here, open circle here. Yeah.
Absolute value with the inequalities, you change like the number sign and then also the
then you also flip it. Okay, so now I'm done with the first part. Second part. The second part is y equals 0.
No worries. Sure. Okay, right. Asa, Miss Carty wants to see you. Not right now, right? She says like maybe in like 5 minutes you could go down and see her. Okay, so now what we want to do is graph y equals 0 if the absolute value of x is greater than or equal to 2. Well, do we all agree y equals 0 is the basically horizontal line on the x-axis? But now we have this restriction. It's the same idea of what we just had. So now I have an absolute value inequality, so I'm going to make my two inequalities. X is greater than or equal to 0. What's the other one going to be? Than or equal to -2. What is the connecting word here? Or, because it's greater than. Okay, so what does that mean for us? That means, where is x -2? 1, 2, right here. Closed circle, going to the left. And then closed circle on +2, which is going to trump the open circle and go to the right. Highlighted part in the middle is not there. And that's what this graph looks like. Okay, you're going to try this one on your own, and then we'll be done. So you're going to graph f of x is equal to 0 if the absolute value of x is less than or equal to 1, and x minus 1 if the absolute value of x is greater than 1. If you want to go see her now, you can. What happened? Or, correct.
Okay guys, because the bell's going to ring in a couple minutes, I just wanted to show you this is what your graph should have looked like. And we are done for today.